Hey, Suzette, thank you for passing that along. Good morning and good afternoon or good evening, everyone. Thank you for joining us. I'm the two of us here from a Cetera High Performance Microcontroller line. We're excited to talk to you about our high performance microcontrollers. This will be the first of a few coming out this year. I think late last year, we announced our AM2X high performance MCU platform, and we are continuing to invest and add to that portfolio. So this particular MPU webinar is about a recent product that we released to market. It is our AM2732 microcontroller. My name is BC Kumar. I'm the business manager for automotive for our Cetera High Performance Microcontroller line. And with me, I have a colleague, Sean. Do you want to introduce yourself?
Hey, good morning, good afternoon, good evening, everyone. My name is Sean Murphy, and I'm the marketing lead for our HEV EV market space in Cetera High Performance MCU.
Cool. Thanks, Sean. So again, as Suzette said, if questions do come up, please do post them on chat. I'll answer them as I go along. In terms of agenda, I'm going to talk a little bit about AM2X high performance microcontrollers. What are we trying to achieve? And then I'll delve a little bit into the 2732, the product we are focusing on today, in terms of what the device itself contains, some of the strengths, some of the target markets we are going after, giving you guys an overview of the scalability that we are going to offer, and the software. When I say scalability, it's in terms of hardware and software and how to get started. So this is the AM2X family of parts that we announced in July of 2021. It is basically a family of devices that combine performance levels that approach what was traditionally in microprocessors, getting you between 400 to 800 megahertz per core at the top end, starting at about 200 megahertz per core at the low end. But getting in all the typical microcontroller advantages that you have in terms of ease of use, in terms of the typical architectures of microcontrollers, real-time operating systems, or bare metal coding, things of that nature. With TI's IP toolbox, what we are also able to bring in is a lot of integration from an analog perspective, integration from a mixed signal perspective, integration from a networking standpoint, safety and security, and for the automotive end of things, AUTOSAR support as well. But the advantages of the AM2X platform goes beyond just the integration piece. It's also the fact that it is a unified architecture or chassis, and we have purpose-built IP integration for different markets, different applications, and different use cases. Targeted at both industrial and automotive. We do have devices with industrial grade specifications and automotive grade specifications. The other big advantage is software compatibility across. We do have a common SDK. We do try and from a driver perspective, have a lot of seamless scalability across. So when you work with a member of one family, you're able to go off and take that software and seamlessly port it across to other families of devices within the AM2X platform. We have three major families, and I'll talk a little bit about these. Last year, when we announced the AM2X in July, we started sampling the AM24 class of products for networking. Those are devices that go between 1 and 4 times, 4 cores. So it's single core to multi-core based on ARM Cortex-R5F up to 800 megahertz, large on-chip RAM, DDR options as well for customers who want to expand their memory, pre-integrated industrial protocols, for example, things like Profinet or EtherCAT and so on for customers, or Ethernet IP for customers, for example, in the factory automation space, in the PLC space, for customers in the motor drive end of things and robotics. These devices have Ethernet switches, CAN FDs, LIN, and PCIe from a communication, apart from SPI and UART and I2C. Focused on factory automation and control, robotics, networking hubs, those types of use cases. The next is the AM26, which actually just went live today, which we are really excited about. These products are sampling right now. These are devices that, again, offer between a single core to quad core, multi-core operation up to 400 megahertz, Cortex-R5F, again, with a large on-chip RAM up to 2 megabytes. Again, there are versions of these that are industrial grade that come with pre-integrated industrial protocols. There are also devices that are focused on the automotive segment. So both aspects of these devices are sampling today. We will have an NPU webinar on the AM26 that's going to come out in April. Don't want to spoil too much of the fun for that webinar, but these also have our industry-leading C2000 real-time control subsystem integrated. So if you're familiar with the C2000 subsystem, that's integrated here. So these are perfect for applications like motor control or motor drives, for grid infrastructure, for power control, for traction inverters, for electrification in the automotive space, whether it's onboard charging or DC-DC converters and traction inverters and so on. Last but not least, on the extreme right, which is a device we are going to talk today, we have the AM27 family. This is a family of devices that they first to RTM. So they are in production today, again, on TI.com. These, again, in the spirit of having something that's IP that's very specific to certain use cases, these have signal processing accelerators on board. We do have an integrated DSP version, okay? We do have the first series of devices have a dual core 400 megahertz. We will move to a quad core 800 megahertz shortly on these devices. These do have, like I said, a DSP on board. These do have radar-specific accelerators on board, very large RAM up to 5 megabytes. I'll talk about that. So perfect for things and applications in building automation that need audio, that need connectivity to some sort of a camera interface. Perfect for things like avionics where you have sensors. You can have the DSP to process your sensor inputs, automotive radar, automotive audio, applications of this nature. So just to give you an idea on the AM2X portfolio, as I was talking about, we do have the several devices that are sampling today or in production. We announced the AM24 in the top right for industrial networking mid of last year. We did go to production with the AM273. So these devices are in production today, both automotive and industrial grade class of products. And the 263 that I talked about, both for industrial grade as well as for automotive. The common theme across all of them, and I'll touch on this now that you look at the overall portfolio, is the concepts of functional safety and security. We do have different grades of safety. We do have certain devices that go up to SIL 2. We have devices that go up to SIL 3. We have devices that do ASIL B as in boy to ASIL D as in David. The other common piece going across all of these is a hardware security module or security that can address secure boot, as well as runtime encryption and decryption runtime security. And last but not least, secure firmware updates. So that is, again, a common theme that goes across all the AM2X platform of devices. So again, moving along, this gives you a little bit of a block diagram for the superset device in the AM2732 family, the device we are talking about today. As mentioned quickly, there are a few pieces I want to touch on. The device does have a C66X DSP running at up to 450 megahertz. Okay, has its own memory, 384K of L2 cache, and a small L1 cache, which is tightly coupled single cycle access sort of for 64 kilobytes. The device also has two Cortex-R5 cores. This is again the superset device running up to 400 megahertz each. These Cortex-R5F cores can be run in the context of lockstep, which is two of the chips running combined together, so to offer redundancy, or to run separately or independently, giving you more MIPS. So you can have this configuration when you boot up. You can't change it during runtime, but when you boot up, you can configure it in either of these two buckets for more performance or for more safety or reliability or redundancy. The Cortex-R5F core is the Cortex-R5 core family from ARM is their family that is optimized for safety or availability or redundancy. It's a great compromise between that. It has some inbuilt features for safety purposes that we do take advantage of. And we do have, again, additionally outside in the chip, which I'll touch on other features. But the Cortex-R5 is a real-time core. It's an MCU core, unlike the Cortex-A cores, which are high-level operating systems. And like I said, it's optimized for safety purposes. It does offer higher DMIPS per megahertz than some of the Cortex-M cores that are normally there today. So it's optimized from a safety standpoint. The Cortex-R5 cores do have a larger L2 memory, which are again closely attached to the R5F cores. It's almost a megabyte, and then it has 3.5 megabytes of L3, which can be shared across all cores. And again, using the hardware security module that you see to the right, you can take different blocks of this memory and assign them to different cores. So you can firewall applications between different cores on these devices. One other very quick point that I'd like to make on these devices, we do offer, you do see a hardware accelerator out there. This does do stuff like FFTs and so on, 24-bit, that can be used for specific applications like radar. There are a lot of different, again, this is a superset. You get an overview of all the different connectivity and the I/O features in there. It does offer Ethernet connectivity. You do see the 10100 MAC switch out there. Apologies for that. We do offer multiple SPI ports. We do offer MAC-ASP, which is I2S for audio. There is a QSPI for connectivity to external flash. That's offered on these devices. There is I2C. We do offer both an ADC on board and PWMs on board on this chip. And of course, RS-232s and GPIOs. We do have a CSI port on this device and CAN-FD as well. The CSI can be attached to an external camera that has its own, let's say, the signal processor ISP out there. We do offer Aurora, which is a LVDS-based instrumentation or a high-speed debug interface. So the superset, you can see there are different devices with different capabilities within this family, but it's a pretty rich collection of IOs on this. We do also have a dedicated PMIC. We work with our TI, as you know, as a dedicated power management IC team. We do have a dedicated PMIC available for these devices as well. So you do have the option to go with discrete power management solutions or use a PMIC as well. Some example applications for this. Again, this is not limited, and some of this, I think some of our customers have gotten ahead of us in terms of how they're envisioning using all these different features. I talked about, for example, avionics. We do have customers in that space that are using this for things like engine control. They're evaluating this. In terms of building automation, there are customers who are looking to use the audio capabilities of this and use it in the context, put a very simple audio analytics engine to that are available in the market, and they're able to do some very simple audio association, sound classification types of applications. You can also use the radar hardware accelerator connected to some of our radar chips that we have, like the IWR's class of devices, 6243 and things of the nature to do occupancy detection. We do have, as you saw on the previous chip, 2 CSI ports that allows you to do attach it to 2 different mimics to get a much more granular, a much more high resolution occupancy detection solution. Can be used for low-end machine vision, again, used for cameras with ISPs integrated, getting a digital output through the CSI. You can do some processing on the chip, things like robotics on the automotive side for premium audio amplifiers using the audio capabilities of this chip. So you can use the safety, you can use the security pieces, you can envision, in an EV to use the safety for the safety chimes, but you can equally, again, from an audio perspective, do things like noise cancellation and things like that. The C66X DSP is one of the highest performing audio DSPs still in the market. And again, I talked about automotive radar. So it's a fairly rich collection of applications. And again, we do hear of new applications or new use cases that our customers are thinking about with a device like this, with a combination of a high performance microcontroller, large memory, a DSP, safety and security capabilities, some combination of these. So in terms of audio, let me talk about this really quickly. The C66X DSP that TI has, we do have other DSPs out in the market where people have ported Dolby DTS on those. So it is our full intent to, as those requests come up, to work. We do have third-party partners from TI that specialize in porting and supporting Dolby and DTS solutions on TI DSP platforms, and we can share that with our customers. On these devices, on the first set of devices, there is no direct display output. Like I said, there is an LVDS out. So it is used for debug purposes. So it's an LVDS out, not an LVDS in. So the initial set of 2.7 or the AM2X devices don't have a direct display interface. Those are devices, as you saw in the portfolio roadmap, we do have plans to increase performance and also go lower cost. So there are those types of portfolio plans that TI has in the future to continue to build out our AM2X platform. So in terms of what we have to get started right now, I'm going to touch a little bit on the software coming up in the next couple of slides, but the MCU Plus SDK is available. I think what you see in red font and underlined are links that take you directly to the location on TI.com. TI does have a resource explorer. We're really excited about it. It's a one-stop shop. You can go there. You get access to documentation, to tools, to demo code, to example code, things of that nature. We do have the MCU Plus Academy from TI. That is a training portal. And again, we do have the link there. We do have training material as well for these devices. There is an EVM that's available right now on TI.com, along with the schematic, the layout. We do have, of course, things like the IBIS models and thermal models and things of that nature available on TI.com for these devices. And last but not least, of course, silicon samples are available now on TI.com. So all the normal things you do expect to find are available. These are supported on the E2E forum as well. If you do have a TI FAE that is assigned to you, and again, you do have that option or that avenue as well to get in touch with us to answer questions as needed on these devices. So having said that, I do want to spend a couple of minutes on this call talking about our SDK and the benefits that the MCU Plus SDK and the benefits that it provides. The big thing is, I think what we've done is simplified, again, looking at the MCU world, simplified some of the drivers that we have. We do have a graphical user interface configuration tool. We do have several examples that are part. You can look at it, come at it through our Resource Explorer and go through the SDK to debug and run with CCS, Code Composer Studio. The most important piece is we do have a lot of examples. I talked about single core and multi-core, especially on the multi-core piece. We do have a very low latency interprocessor communication capability built in on the software and the drivers, but we do offer the multi-core bootloader examples as well. Available on part of our SDK and part of our Resource Explorer. From the MC, we do have, again, a lot of our drivers. As we have done this, we focused on two things: low latency and low memory usage. And again, if you do have feedback on our drivers, please do provide that over our E2E or directly through your FAE. We are, of course, always open to improvement or where possible, optimizing for certain use cases or applications. The SDK itself comes natively supporting bare metal or no operating system, no RTOS, or free RTOS. In addition, we do have partners that we work with, for example, with Wittgenstein on Safe RTOS. We do provide MCAL drivers free of charge. Again, everything on TI.com is, of course, free of charge, what TI provides from our side. So we do provide MCAL drivers, and we do work with AUTOSAR partners there as well for AUTOSAR support. So those are third-party Safe RTOS, AUTOSAR, and if there are any other operating system requirements, other operating systems that y'all need supported, please do let us know. In terms of tools that we provide to ease your development, we do have the sysconfig tool that is available that you can go and configure the chip. MCU Plus Academy, I talked about from a training standpoint, Resource Explorer. We do have our C language compiler. We do have CCS plus FreeRTOS live debugging capability. We do have board flashing tools like UniFlash that we support. From a debug perspective as well, we are supported with Lauterbach. So on these devices, you should be able to find them on the Lauterbach website. So that's also available. From a library perspective, in terms of connectivity, we do provide for the key connectivity peripherals for our devices like the AM243 on TI.com that supports USB. We do have tiny USB libraries. From an Ethernet perspective, we do provide the lightweight IP stack, LWIP stack, TSN. I talked about industrial networking. We do provide those protocols like Profinet, like EtherCAT, like Ethernet IP, and so on. From an application perspective, just as an example, we do have motor position encoders that are supported, control algorithm examples. I talked about interprocessor communication for multi-core, whether you talk about DSP to R5F or within the R5F multi-core world. So we do support all of that. From a safety and a security standpoint, again, our goal is to make things easy from a development perspective. We do support secure boot capability. We do support, as I said, crypto acceleration. We will be supporting IPsec and TLS. These are AUTOSAR ready. What I mean by that is MCAL support. Again, this is MCU plus SDK overall. Looking at the features of the specific chips that you pick, there are certain elements that will be supported. Of course, if the feature is not supported on the chip, we won't support some of those. So the 2732, for example, doesn't support USB. We won't, of course, have a USB driver there, but we will have drivers as we go forward in time that will support how to use the hardware accelerator, how to use the LVDS interface, Aurora for debug, and the CSI and things of that nature. Going back to the safety and security piece, I talked about being AUTOSAR ready with MCAL, which is what we mean. We do work with some of the leading AUTOSAR companies like Vector and ETAS and Electrobit and so on. Some of them support AUTOSAR already today on the 2732. Some of them we will support them as our customers require support. I did forget KPIT there. I talked about Safe RTOS support. The other thing we will be providing, I think over time, from a safety perspective, we do already have for the 2732 things like the preliminary safety manuals. We do have an FMEDA draft that's available today. And as we go through the rest of this year, in the beginning of next year, we will go through the certification and then offer the final safety manual, the final FMEDA. We will offer safety diagnostic libraries and compliance support packages like we do on our TMS 570 Hercules class of devices. I talked a little bit about the MCU Plus Academy. There is a typo here, which I'll correct. It is an AM273 EVM quick start guide, and that will be available. We will offer the MCU Plus SDK fundamentals that are there and the more advanced topics like multi-core communications, DMA, functionality, and things of that nature, which is very, very typical. If you're familiar with the AM243 This is very, very similar in the MCU Plus Academy. In the debug and trace tools, again, we do support Code Composer Studio. We do have the C66X, as I mentioned, a DSP, the R5F. The HSM has an M4 inside, so it's a true hardware security module on the chip. We do support Evita from an automotive perspective as well. So we do support that, as I mentioned, it's FreeRTOS aware, multi-core debugging, and capabilities are supported on these devices. And that includes the C66X processor and the R5F MCU core. We do also support Trace32, again, supporting the R5F and the C66X DSP and the M4F on these devices. So it's a pretty broad, so if you're familiar with Lauterbach, you can go down that path. If you're familiar with the Code Composer Studio, you can go down that path as well. Just a quick overview of the sysconfig. This is just a screenshot. This is for a different device, but again, it's 273 is going to be very, very similar. You'll have a very similar view to go and configure the chip. We do have CCS projects that are already there for 273. When you do go look into CCS, you can go pick the modules and configure them and get your configuration files, a header files, automatically to sort of go figure out, what's going on. This is the Resource Explorer. Again, this is a screenshot of the AM64. It's very, very similar for the 273. When you go in and look, and it's just a combination of gives you the examples, gives you the development tools that you need to pick, gives you the driver porting layer, gives you the both the board and SoC peripheral drivers, examples, APIs. So it's a pretty rich Resource Explorer that we have. The whole idea, again, is to reduce your evaluation time by allowing browsing and running examples without having to download and install everything and do everything via a browser. That is the whole purpose of the TI Resource Explorer to go do. So you can download. It also allows with links to then look at what you need to download from ti.com directly. It allows you to browse examples and documentation before you install anything on your hard drive, just so you're sure that you can do. And you can also get to CCS Cloud and get started without installing from a CCS perspective as well. So again, the key things on the AM2732, just to summarize, it's a lot of high performance MIPS processing between the R5F and the C66X. We do have a very efficient RAM architecture between dedicated RAM for the different cores, between a central shared RAM, and using the NPU to firewall between the different cores so that you do have a lot of flexibility. We do have external flash on these devices, so there's a lot of flexibility. So you can use non-volatile memory going anywhere from 2 meg. You can go all the way up to 32 meg, depending on your application needs in terms of performance and your application needs in terms of memory capability. You can also do, like I said, secure over-the-air updates. From a connectivity perspective, I gave just a few examples here. We do have Ethernet capability, CSI2, where you have 4 lanes per CSI port. We have 2 of them running up to 600 megabits per second. We do have the Aurora LVDS out interface with high-speed debug, CAN-FT, MEC-ASP for audio, and so on. Safety, I talked about, we do have a strong safety. The R5F code itself is very, very safety-centric, but equally on chip, we do have a lot of ECC across all memory. We do have redundancy. We do have BIST capability that both start. You can run at boot, but you can also run at any time during your operation. We do have BIST. We do have watchdogs, monitors, compliance support packages, and so on. We do have a robust security capability. I talked about the HSM. We do support both symmetric and public key, RSA and elliptic curve and AES. We do have a random number generator on board. We do have different feature set configurations from a safety, from a scalability perspective, pin compatibility across of those. The key thing from a supply reliability perspective, we are dual sourced across the wafer fab test and packaging in the supply chain, those operations. TI continues to invest. You can go and look at our every quarter. We do talk about investing both in terms of wafer fab and in terms of packaging and backend facilities. And I talked about the software. There's no NRE or license fees for software delivered by TI. We do have MCU Plus SDK and the Resource Explorer and MCU Plus Academy on TI.com. We do have free MCAL drivers as well for AUTOSAR support on this. I do have a slide on memory architecture on the flexibility. I won't talk about today, but it should be part of the presentation and the slides that you can download. Again, as Suzette said in the beginning, please do visit ti.com/NPU to get more information on this and also other webinars that we have on ti.com and archived recordings. This particular session is also recorded. So I do appreciate, I did go a minute over. I do apologize for that. I know your time is really important. I do want to respect that. I hope this gave you an introduction, a lot of information. Please do get in touch with us. We are excited about this part. It's a continued journey for us on the AM2X platform. We will have more of the AM2X NPU webinars as we go through this year. Again, thank you very much for your time. We do look forward to hearing from you if you need more information or need any help. Thank you.
Thank you so much, VC and Sean, for hosting. Yes, thank you so much for hosting this webinar. And as VC mentioned, you can find the full webinar schedule at ti.com/NPU, including another upcoming AM62X webinar that we'll be doing in about a month. So thank you, everybody, and I hope you have a wonderful rest of your day.